Hello everyone. In this video, we are going to discuss about procedure calls. So suppose we are having a procedure call statement like this. P within parenthesis x1, x2, dot up to xn. That is a name of the procedure is P. So the procedure P must be called with n parameters. Then the three address statement for this procedure call is parameter x1, parameter x2, dot up to parameter xn. Then call p comma n, that is param x1 must be evaluated first, then parameter x2 up to parameter xn, then call p means the name of the procedure, the n is the number of actual parameters. So this is the sequence of three address statements must be generated by using the syntax director translation. And whenever a procedure call occurs, some sequence of actions must be done. So for example, consider the C programming statements like add x comma y, then void add int a and int b. Consider this example. Here main is a calling procedure and add is a called procedure. So here whenever the procedure call occurs, some sequence of actions must be done. First one is the space must be allocated for the activation record of the called procedure. Activation record means it will have information about the procedures, for example local variables in the procedure, parameters in the procedure, and return address, etc. So all the informations must be stored in the activation record. So we will discuss about activation record in the runtime storage management. So first activation record of the called procedure must be done, then these parameters must be evaluated, then return address must be stored. So because whenever the program is executed, the main procedure, calling procedure is main, so main function is executed. So whenever a procedure call occurs, the main procedure is temporarily suspended. Execution of the main procedure is temporarily suspended, and control is jump is performed to the called procedure. So after executing the called procedure, again the jump must be performed to the calling procedure, right? Because the execution must be resumed at this point, so that the return address must be stored. Then only after executing the called procedure, control must be returned back to that location. So return address must be saved. After that only jump to the called procedure must be performed. Similarly, after executing the called procedure, a return must be performed. If you want to return some value, return statement must be used. Otherwise, after executing the called procedure, directly the control will be returned back to the calling procedure. But before performing the jump operation, some sequence of actions will be done here also. So first the result of the called procedure must be stored in a known place. Then activation record of the calling procedure must be restored, because now the calling procedure will take over the control. Then after activating the activation record of the calling procedure, jump is performed to the calling procedure. So these are all the actions must be done when performing a procedure call statement. Now we will discuss about syntax director translation for producing three address statement for the procedure call. So this is the syntax director translation to produce three address code for the procedure call statement. So this represents the grammar rules for the procedure call, and these are the semantic actions for each rule. So a statement tends to call id within parenthesis elist. So it represents procedure call statement. Id means name of the procedure. So procedure call statement means it is add x comma y, right? So procedure name, then within parenthesis we need to specify the parameter list. So this e list may be e, that is the parameter may be a single parameter or more than one parameter. For more than one parameter we can use this second rule, e list tends to e list comma e. So this is a recursive procedure. For any number of parameters we can use this. Finally the e list must be replaced by e. Then these are the semantic actions. So here for for evaluating the parameters, we are going to use the data structure as Q data structure is used. So EList tends to E. The semantic action for this one is initialize Q to contain only E dot place. That is E, the parameter E must be evaluated and it must be, its result must be stored into the Q. So E dot place represents value of E that is stored into the Q. Then the action for EList tends to EList E means, EList comma E means already Q will have some values. Then this E will be appended to the end of the Q. Then S tends to call ID of EList. So here this is a statement. So here we need to produce the list of parameter statements and call, right? So that this is a semantic action. So for each item P on Q, because the parameters will be stored into the queue, so for each item a loop must be performed for each item P on Q. Emit param P. That is, emit means it produces the statement in an output file. So param P will be produced. So this will be executed for the number of parameters in the queue. Then finally call id.place. id.place means name of the procedure will be done. So we will see the parse tree for this. Consider the example, add a comma b. The procedure call statement add a comma b. So what is the parse tree for this? Start symbol of the grammar is yes. So in C program we don't have call, right? But in some programming languages call is the keyword used for representing call statement. So for if we don't want we can remove this. So call id open parenthesis EList close parenthesis. Now this EList, here we need two parameters. So EList is expanded by using EList comma E. Then this EList is expanded by using E. So first in bottom up fashion, first the reduction is coming over here. So what is the semantic action performed here? Initialize Q to contain only E dot place. So this E is evaluated, and actually here some expression may be there, and now it is ID and that identifier is A, right? And this identifier is B. So this result must be stored into the queue. Then EList comma E. The semantic action here reduction is performed. EList comma E is reduced to EList. So the semantic action is append this E dot place to the end of Q. So E dot place means B. It should be appended at the end of the Q. Then the reduction is performed for the yes call ID open parenthesis EList close parenthesis. So here for each item P on Q, first P is A. So emit, what is the 3 address statement produced here? 3 address code. So param P. What is P? A. Then another item is there. So now P is B. So emit param B. Now there is no item on Q. So emit call id dot place. So call id. This id is add. Name of the procedure is add. So call id, and here the number of actual parameter, the code is the semantic action is not included for displaying number of actual parameters, but if we want we can use elist.n dimensional for storing the number of actual parameters. So this is the semantic action for performing 3 address statement for procedure calls. Thank you.